Hello guys, welcome to another tutorial. In this video, we will discuss how to make a geological map using ArcMap software package with the help of datasets that we can readily download from a number of different sources across internet. Now, as you can see here, this is how the final map is expected to look like, and for the purposes of this tutorial, we're going to download some geologic data corresponding to Europe, and we are going to clip those data to the administrative boundary of Switzerland. And then we will be making use of the map layout functionalities of ArcMap to design and create a beautiful map like this. So without further ado, let's get started. So the very first step would be to scout for some geological or global geological data. And if you were to do a bit of random research, I'm sure you will manage to find a number of different sources from which you would be able to download a number of different datasets. But for the purposes of this tutorial, I'm going to download my geologic data simply by googling World Geologic Maps USGS. And usually the very first response that you see would be the portal that I would access to download these datasets. So let's click over here. And as you can see over here, we have access to download geologic maps for a number of different regions across the entire globe. So we have Asia Pacific over here. And we have the Caribbean region, the European region, and it's not just the GIS data that we have access to. Along with the GIS data, we do have access to different sorts of publications. For an example, if I click over here, you can see that it's actually directing me to a document on geology, oil and gas fields and geologic provinces of Europe, including Turkey. So it's quite informative and helpful. And if you're after the geological data in the form of GIS data, what you can do is you can actually click on one of these options over here. So we have the option to download the faults of Europe, including Turkey, as a shapefile. And we have the generalized geology of Europe, including Turkey, geologic provinces of Europe. But in this case, what I would be looking for is the generalized geology of Europe, basically. And after I download that, I would be able to actually clip that dataset using a specific administrative boundary just to get rid of the unwanted stuff. And we'll get to that in a minute. So what I'm going to do is I'm going to first download this generalized geology of Europe, including Turkey dataset as a shapefile. So let's click over here. So as you can see, this is the downloaded file. So let's go to the downloads folder, try to copy this and transfer it to our working folder. Yeah, so as you can see, this is the zip file that I downloaded just a couple of seconds ago. So what I can do is I can right click over here and I can extract the files just so that I would have access to the individual files that kind of forms the shapefile altogether. So as you can see over here, these are the different files that kind of forms the shapefile. And if you were to use a GIS software like QGIS or ArcGIS, you would be able to open up and view this shapefile. So that's exactly what we're going to do next. So as I told you guys, I'll be using ArcMap to create this map. So I'm going to open up my ArcMap application. Alright, once you open up your ArcMap application, you can see that the entire interface is pretty clean. So you can open the shapefiles either by connecting the folder through this catalog, or you can just simply drag and drop the shapefiles. Even though I could simply drag and drop the file, I think just for consistency, let's try to establish a connection to our working folder and we'll try to work directly from there. So I'm going to head over to this button and click over here. So this would be my working folder and I'm just going to connect to that. And now if I expand this, you can see that we have this .shp shapefile. What I can do is just drag this and drop it over here to your working interface, and well, this is how it's supposed to look. So in the first instance, it's quite normal that the dataset might not really make much sense to you guys. So what we can do is we can actually do a bit of exploration. Maybe we can check some metadata to understand what kind of a dataset that we're dealing with. And in addition to that, we can also have a look at the attributes table. So let's go over here and maybe open up the attributes table. So over here you can see the different types of fields. And since we are dealing with different rock units belonging to different geological time periods and ages, I don't think we would be necessarily making use of any of these different fields. However, this GLG field is actually going to be quite important. Now, when you check it for the first time, I'm sure that these notations might not really make sense to you much. However, if you head back to the document that I was referring to at the beginning of the tutorial, and if you scroll down, you will actually be able to get sort of an explanation where they clearly state what each of these different notations actually mean. So before we actually jump into the next step, why don't we head back to that particular document that I was referring to, and we'll try to see how they have interpreted these different types of rock units that are belonging to different geological ages. So if I head back to this portal again, and if I open up this document right over here. So this is basically the document which explains the dataset, and if I scroll down just a little bit more, you can see over here what exactly those different types of notations are supposed to be. So we have the sedimentary rock units over here, and we have igneous and metamorphic rock units over here. So if you do a side-by-side comparison, you would be able to see that this J over here basically refers to sedimentary rock units of Jurassic period. This P would mean Permian, and C over here would mean Carboniferous. Now it would be ideal to actually sort of transfer these explanations as another field into our attributes table, but I'm not going to do that for the purpose of this tutorial. I'm just going to stick with this notation. However, with the understanding that we have the possibility of always referring back to this document in case if we don't really understand what any of these different notations actually mean. So once you have loaded up the data, I think it would be quite wise to head over to the properties of this particular shapefile layer and check what sort of a coordinate reference system they're actually using. So we can head over to this source tab, and right over here you can see the type of coordinate reference system that they're using. So it's WGS 1984 Lambert Conformal Conic Projected Coordinate Reference System. And one of the cool things when using ArcGIS is that whenever you drag and drop a particular shapefile layer, the coordinate reference system of the data frame automatically takes the coordinate reference system of the very first layer that you dragged and dropped. Now, how can you be sure of that? If you head to these layers and right click and go to properties, if you head over to this coordinate system tab, you will see that now the coordinate reference system of the entire data frame has been changed to match the coordinate reference system of the shapefile that you dragged and dropped as the very first shapefile layer. So that's all good. So now my next objective would be to use an administrative boundary of a particular country and try to clip this dataset so that we don't really have to use this massive shapefile or this massive dataset when creating our map. So for that, I'm actually going to use the administrative boundary of Switzerland. No particular reason though. And if you're making your own map, you don't really have to restrict yourself to the administrative boundary of Switzerland. It can be a country of your choice. And it doesn't really have to be Europe either. You can actually head back to the data portal and download the data which correspond to a completely different region in the world. So luckily I do have a shapefile which corresponds to the administrative boundary of Switzerland. Now in case if you don't have the shapefile data of the country that you are interested in, DIVA GIS is actually a good portal that you can head over to. So it can be accessed using this URL, diva-gis.org. And if you go to free spatial data over here, you can head over to country level data, and from here you can actually select basically any country that you wish to download the data for. So let's say for example if I go with Panama, all I have to do is select administrative areas and click OK, and it'll actually download the information in the form of a shapefile for you guys. And it's not just the administrative areas that you have access to, you actually have access to quite a number of different things which might come in handy depending on what you're trying to do. So in this particular demonstration, I will not really go ahead and download the data because it's quite self-explanatory, and I have already downloaded the administrative boundary of Switzerland. So I'm just going to make use of that particular data set. So let's open up the catalog, and if I refresh this folder, you will see this Switzerland folder, which I just actually copied into this folder. So that's why you didn't see that before. And when you download your own shapefile, you will be actually able to get access to the corresponding shapefile of the administrative boundary of the country of your choice. So what I'm going to do is I'm going to select the shapefile of Switzerland and drag it and drop it on top of this. Well, unfortunately, the color that got assigned is exactly the same color of the other shapefile, so you probably might not be able to see the difference. So what I'm going to do is I'm going to maybe change this to something completely different so that you would be able to see which part of this original geologic data shapefile is bounded by the administrative boundary of Switzerland. So ideally what I would do is I would actually perform an intersect command and try to sort of get rid of these unwanted data and only retain the geological information corresponding to Switzerland. However, before you run the intersect command, you have to make sure that both of these shapefiles are actually in the same coordinate reference system. And typically when you download data from DivaGIS, that dataset is going to be in WGS 1984 Geographic Coordinate Reference System. So you can have a quick look by right-clicking over here, and if you go to Properties, over here you can see the coordinate reference system. First of all, it's not a projected coordinate reference system, and it's quite different from the coordinate reference system that was assigned to this geologic map dataset. So what we can do is we can actually try to create a copy of this shapefile by simply exporting, but while exporting, we can assign the new coordinate reference system of this particular shapefile to be the same exact coordinate reference system of our data frame. So that way we are kind of reprojecting this shapefile into a completely different coordinate reference system. But the way that we are doing it, it's not really a straightforward method, but all that matters is it works. So we can right click over here, go to data and go to export data. Quite important, make sure that you are actually picking this option. So the coordinate reference system is actually going to be the coordinate system of the data frame, not the layer source data. And as the output, I'm going to name this as Switzerland Projected Coordinate System. So when we have a descriptive name like that, we would be actually able to distinguish that from the other files. And go ahead and click OK and click yes. Alright guys, so now you can see that we have a new shapefile over here, and if you right click and go to properties, what you will see is that the new coordinate reference system that was assigned to this shapefile is exactly the same coordinate reference system of this original geologic dataset. Alright, now what we can do is we can just go ahead and run the intersect command. So if you click over here in the search panel, you can just simply search for the intersect tool. It's going to be the first one. And what we are trying to do is we are trying to intersect two different layers, and those two different layers are going to be first the administrative boundary of Switzerland, and it's going to get intersected with this original geologic dataset. So just drag that and drop it over here. And now we can actually specify the output path as well. We can give it a name, geologyswitzerland.shp, and just simply click OK. Alright, so once the command gets executed successfully, maybe we can get rid of this search panel, and we basically can get rid of all these unwanted datasets now as well. We won't be needing this one. I think I'll still keep this Switzerland PCS dataset. And what we are after mainly is actually this Geology Switzerland dataset. So if you right click and go to attributes table, now you can see that quite a number of fields, and most of these fields are not really going to be necessary for us. What I'm interested in is actually this particular column, this GLG column. Now before we go ahead and start putting this into a map, you can see that there's actually a split even among the same geological period. For example, if you refer to the notation N over here, you can see that not all the N's are actually grouped together as one feature. So if you really want, we can actually make use of this shapefile just as it is, but I think I'm just going to go ahead and perform one more step just to make sure that we group all of these common geological notations as one single feature. So that means we are going to actually group all these N's together, and these H2Os, which I believe is how they specify the regions with water, are going to get grouped as one specific feature, and so on. So let's deselect all of these and go to geoprocessing and perform this dissolve command. So the dissolve command basically does that. So what we can do is we can drag this and drop it over here. And quite important, when using the dissolve command, we have to basically input the specific field that we intend to use this to perform this dissolve operation. So in this case, that's going to be this GLG column or GLG field. And similarly, we'll have to specify the output location. So I'm going to still name it as Geology Switzerland, but maybe we'll just put a small note here saying that it's the dissolved geology shapefile. Alright, let's go ahead and execute that as well. Alright, now if you deactivate this and if you open up the attributes table, you would be able to see that we don't really have those unnecessary columns anymore, and all the different geology types are actually kind of grouped together. So let's say if I'm referring to the Permian period, so all of these different rock units are actually belonging to the Permian period, if I'm not mistaken. And similarly, if I want to refer to the Jurassic period, so all of these different regions have the presence of rock units of Jurassic period. So that's how that works. And now I think most of the data preparation work is done, and I would say like 99% of the data preparation work is done. Now all we have to do is basically use a specific coloring notation to make sure that we actually view the different types of geological periods using a different specific color. So what we can do is we can go to properties and go to symbology, and under categories. So over here, if you assign unique values, what we can do is we have the luxury of actually specifying a unique field by which the coloring is actually going to get assigned. So in this case, you can see that we have a unique, we have a field called GLG, and within that we have different unique features. So each feature will be getting its own unique color. So that's basically how this works. And let's click add all values. By the way, if you are not really happy with this color ramp, you have access to a number of color ramps over here, but for this tutorial, I'm just going to go with this. If you would like to make separate changes, you can simply do that by clicking right over here as well. Now, for example, when it comes to the regions that show presence of water, I think I would like to assign some sort of a bluish color for those regions. So let's say if I were to assign color like this, and if I find that blue has already been assigned to another geologic period, you can always click and make changes to that accordingly. But I think for my case, we are all good to go. There are other values that are not really represented by each of these different feature names. All of that will be actually represented by this particular color. But in this case, since we don't really have any of these other values, what I can do is I can simply just click over here to get rid of this representation of these other values. And after that, we can click apply and click OK. So finally, this is how the map looks, and right over here you can see sort of the legend. So if you want to see what each of these different colors actually refer to, you can always head back to the original document and have a look there as well. Alright, now let's move on to the layout view and start preparing our map. So there are actually a couple of ways to get to the layout view. Now if you head over to this button right over here, you can see that we have two buttons right next to each other. The one that we are currently working on is called data view, and there's another one called layout view. So if I want to head over to the layout view, all I have to do is just click over here on this button. So that's what I'm going to do. I'm just going to click over here on this layout view button. And what this lets us do is it's actually going to let us take care of things like the orientation of the page and basically everything that has to do with preparing a map, adding the legend, adding a north arrow, adding a scale bar, stuff like that. So the very first thing that I would like to do is to actually change the orientation of the page, because I think when we look at the geographical spread of Switzerland, I think a map that's presented with a landscape view would be much better suited compared to a map that's presented with a portrait view. Well, there are certain countries that would actually fit in quite nicely with a portrait view. For example, a country like Chile or Vietnam, which kind of stretches vertically compared to a country like Switzerland, which really has a spread to west and east. So to change the orientation, what we can do is we can actually go to this layout panel. Now, in case if you cannot find this layout panel, all you have to do is right click over here and you can activate it simply by clicking right over here. So you can just drag it and drop it over here just so that it won't take up space in my working space. So if you go to change layout, you would be able to select a number of different layouts and orientations, well, page sizes and orientations. So in this case, I could either go with A4 landscape or maybe A3 landscape. I think let's go with A3 landscape and click finish. And after that, what you can do is you can sort of extend the boundaries of this bounding box, if you will. I'm not going to actually put it all the way to the edge of the page because I would like to still retain some space to add the coordinate information at the edges, like this. And after that, if you would like to move this map around, you can actually use the span tool, and with that you can see that quite easily you can move this map around without any issues. And of course, if you would like to change the zoom level, you can try to use this zoom in and out buttons. So if you would like to zoom out, yeah, you can make it smaller just like that. And if you think that you still have some real estate on your working canvas to make it a bit larger like this, yeah, you can increase the size as well. Alright, so the next important thing that I'm trying to do is I'm actually trying to import this legend over to the map. So if you want to import a legend, what you can do is you can go to insert and go to legend. And from here you will have the choice of actually specifying what kind of data that you would like to import under the legend items. So in my case, it's actually going to be just the Geology Switzerland Dissolve dataset. So I don't really need this Switzerland PCS. So anything that you don't need, you can get rid of that by simply clicking this button over here. And similarly, if you wanted to add that back, what you would do is you can actually select the corresponding item and click this arrow right over here. So I'm just going to get rid of that and click next. Alright, now from here you can give a name to the legend. You can either keep it as legend or you can just specify a name of your choice. You can change the color and the font size. But since we're doing this for the very first time, I'm just going to go with the default settings, and once I see how it fits to the rest of the map, if I think that I would like to make some changes, I could always come back and revisit these items to make those particular changes as I need. So let's click over here next. Do I need a border for the legend? I think I would add maybe a slight border like this. And background and drop shadow, I'm not really bothered at this particular moment. And we can go ahead and click next. And the spacing between the items, again, I'm not really bothered by the spacing at this particular moment. In case if I find that it's not really according to my expectations, I can always revisit and make these changes accordingly. But for the most part, these default settings actually might work. So let's click finish. Alright, so this is how the legend basically looks. Immediately I kind of noticed some spacing issues, and there are certain texts that I might not necessarily need. And in terms of the font size, I think I would also be interested in increasing the font size a bit, just so that it'll be visible and properly readable. You can either retain the legend as a single column like this, Or if you wish to have multiple columns for the legend, you can actually do that as well by simply going over to properties. And over here under the items, if you select place items in a new column, and if you increase the number of columns, let's say if I wish to go with 2 columns and select apply. Okay, now you can see that the whole thing actually gets broken down into 2 different columns. However, by looking at the spacing arrangements, I think it would be good to have all of these kind of arranged in one single column instead of having it in 2 different columns. So let's go back to properties and basically set this back to be 1 and apply and click OK. Now as you can see, it just reverted back to be just one single column. Alright, now what I'm going to do is I'm actually going to get rid of this GLG, this word right over here. So one cool thing when preparing maps with ArcGIS is that if you wish to actually just get rid of a particular name or a subheading of a layer, just click once over here and it'll turn to be in this editable mode, and you can just simply hit delete and that'll kind of get rid of that GLG text. And the name of the layer, again, I can click once and rename this to be maybe something like that. And now that I'm looking at this legend, I think that maybe we can get rid of this legend sort of title as well, because I don't really see the point of having that. It's pretty self-explanatory that it's legend. So if I go to general and if I untick this show box, I think we'll probably get rid of the legend as well. And while we're at these legend properties, we can also go to items and make some changes to the font size of these individual blocks as well. So we have already selected this geology item over here, and we are not going to apply that to all labels, but we are going to apply that to class labels. And what we are going to do is we are going to make it bold and probably increase the font size to be, well, let's try 16 and see how that looks. Yeah, I think that's pretty good. And similarly, if you would like to increase the font size of this geology heading, what we can do is we can go to heading and make sure that we are just a little above the font size of each of these different items. So let's go with 18. That's just going to slightly increase the font size as well. Just click OK. Alright, now what we can do is we can actually add a title. So to add a title, we can go to insert and click over title over here, and we can name this as Geologic Map of Switzerland. So that should be displayed right over here in the middle. And of course we still have the possibility of increasing the font size and the font type as well by heading over to change symbol over here. And I'm going to maybe go with, let's say, about 41. And if you even fancy a different font type, you can actually go with a font type of your choice as well. But I think I'm going to stick with the Arial font type unless I can find something cool from here. Well, I guess not. So let's just stick with the Arial and make it bold. Click OK. Yeah, that really stands out from the rest of the items of the map. Now we still need 2 things. We will need a north arrow. So again, head back to insert and go to north arrow. I would usually prefer to go with this Esri north arrow when working in ArcGIS. That'll be placed right over here. And one more thing, quite important, it's quite important to have a scale bar as well, just so that if people really want to get some sort of an understanding of the distances across the different regions of the country, a scale bar would actually massively help in kind of deducing the distances that might not really be apparent when you just look at the map for the first time. So of course you have scale bars that come with different types of units. You can either go with miles or kilometers. I of course prefer to go with kilometers. I think I'm going to stick to this item over here and click OK. And you can again stretch the scale, but it doesn't really matter because the numbers will get adjusted automatically. So I think maybe something like this would be quite alright. Double click over here and increase the font size as well. So we can make it bold and of course increase the font size to be, I think I'll go with 15. Alright guys, I think we are pretty much done. However, I would still like to add a base map to this, just so that these empty white spaces wouldn't really, take up much of the space. We'll add some sort of a nice vibe when we add a base map to our map. So to add a base map, you can go to File, Add Data, and go to Add Base Map. And when using ArcMap, you actually have access to a number of different base maps. Now, I think going with this imagery option would be a bit too much because I don't want the attention to be diverted too much towards the base map. So when you're shooting for something like that, I think the topographic map would be ideal in achieving what you're looking for. So let's go ahead and add this map and see how that looks. Well, if it doesn't really work out, you always have the option to go ahead and change it. Yeah, I think exactly what I was looking for. However, if you still think that the base map is kind of grabbing the attention too much, you can head over to this base map under the table of contents and right click and go to properties and increase the transparency just a bit, maybe about 15%, just so that the different features of the base map won't be too obvious with respect to the actual information that you're trying to portray. Right, make some final adjustments and yeah, now we are left with the coordinate information. So what we can do to add the coordinate information would be, again, go to this select elements button and right click over here and go to properties and head over to this grids tab. And what we are going to do is we are going to actually create a new grid. And you have the option to go with the Graticule, but in this case I'm just going to go with this measured grid option and click next. Well, you can set the intervals manually, but again, just to get some sort of an idea in terms of how it looks, what I'm going to do is I'm going to stick with this default settings for the time being and click next again. We will have this major division ticks and minor division ticks. I probably might get rid of these two in the next step. However, let's go ahead and proceed and finish this up. Now you will see that we have a new item called a measured grid. So to apply the changes, just click apply over here. And now you will see this sort of a grid getting appeared along with the coordinate information at the corners as well. So it's basically what I was striving for. However, I would like to make a couple of changes still. So if you would like to edit an existing grid, all you have to do is just select the grid and go to properties. And first of all, when it comes to the labels, of course, I think I would like to increase the size of the labels to be at least about 12. Click apply. However, the changes are not really visible just yet. And when it comes to the lines, I think I would not really prefer to show the lines in this particular case. There are cases where you would benefit from having the lines crossing over the map, but for some reason I think it's kind of a distraction to the information that I'm trying to portray. So let's just go ahead and get rid of that as well. Click OK and apply. Yeah, I think that should do it. So you would still be able to see the corresponding coordinates at the corners. Now, when preparing maps, it's actually a very decent thing to add a note somewhere over here stating the actual coordinate reference system that you're actually using. Because these numbers would not really mean anything to anybody unless they know which coordinate reference system that you're referring to. Because these numbers would be totally different to a different projected coordinate reference system. So before we finish up the map, what I would do is I would actually add a text which gets appeared right over here. I might have to double click and maybe increase the size just a little bit. And for this particular case, since I'm not trying to put too much attention to this piece of text, I would like to apply this italic formatting for that as well. And what I'm trying to say is that the coordinate reference system. Well, what you can do is you can simply copy and paste the coordinate reference system that we saw before. So let's click apply first and get this placed. Let's say I'm going to place this somewhere over here without drawing too much attention to that, but still retaining it as a key piece of information. So what I'm going to do is right click over here, go to properties, go to source, just select this, Control C, and head back to this, double click, and yeah, make sure that you add that properly like this. And within brackets I would like to specify PCS because it's a projected coordinate reference system. Just click apply and see how it looks. Well, it might get distorted just a little bit, so you always might have to reposition it just like this. So finally what we can do is we can go to File, go to Export Map, head over to the folder that you're working in, and you can give this a name. Geologic map of Switzerland. Save as a JPEG, and resolution. Well, the higher the DPI that you assign, the higher the number of the pixels it'll be, and the file sizes will also actually shoot up accordingly. So I think I'm just going to stick with the 150 DPI. Not that I'm going to print this map or anything like that. So this should be quite sufficient just for the demonstration purposes. And go ahead and click Save. Alright, once it's exported, you can head over to the working folder and try to locate that JPEG file that you created just now, and that's this geologic map of Switzerland. And if you double click that, this is how it's going to look in full screen. Pretty cool, isn't it? Now you can actually zoom in, and you will see that you're not really losing the details much because you set relatively a higher DPI. However, if you overdo it, you will actually start seeing some sort of a pixelation, but I think this works pretty well for what I'm looking for. So that concludes the tutorial, guys. I think you managed to learn something new. I hope at least you did. And if you did like the tutorial, you can always show your support by hitting that like button. If there are any questions, just add a comment down below. And always consider subscribing to this channel if you would like to see this kind of cool tutorials on a weekly basis. So thanks for watching, guys. Again, I'll see you again with another tutorial soon.